Planning analytics is great at comparing different business scenarios and helping users make better decisions. Today, I'll explain how decision optimization can help planning analytics users raise the bar and optimize the results by considering a complex set of variables, constraints, and cost weights, thus simulating and optimizing thousands of scenarios to identify the best, most optimal decision. Previously, this type of integration required manual coding and TM1 API use to configure the connections. Today, available in Workspace 68 and greater, the integration is native with Watson Studio. Watson Studio data assets are directly associated to TM1 workspace views, and Watson machine learning jobs are runnable from Planning Analytics action buttons. I'll illustrate this integration through a brief example. This is an example of a fictitious electrical company. It needs to answer the ongoing question of which power generators should I run in order to satisfy the demand for electricity. Considering the different coal, gas, and diesel generators and purchasing from external sources. This planning process can occur monthly, weekly, or daily, depending on circumstances. Changes in production can emphasize short-term scheduling and long-term managing uncertainty and being able to provide kind of non-interrupted service or uptime to its customers. Each generator has characteristics such as the initial production, the existing production level before the optimization period, the min and the max generation levels of the generator, and the operating maximum over which significant pollution is created. Minimal up and down times, specifying the time a generator must be off once it's turned off. The maximum ramp up and ramp down times. Number of times a generator can change its status per hour. The startup fuel and the linear operation fuel consumption. Lastly, the CO2, carbon cost of pollution from the power generation. On the first tab of the application, we saw the characteristics of the electricity generators. On this tab, the next tab, we have the predicted demand, the load. This is the estimated predicted demand from residential and commercial customers, institutional customers, for the demand for electricity over time. This demand can be calculated based on historical information, but also enhanced using predictive analytics, Watson Studio modeler type capabilities. Okay, in this part of our demonstration, I'm going to go into split screen mode because we're going to start to talk about how planning analytics integrates with our second product, Watson Studio Decision Optimization. The next tab in our planning application is the Kpi tab. It's populated with results from our production plan, our optimization from decision optimization. It's going to include KPIs such as our overall fixed cost, the variable cost, and the startup costs. Costs for the production plan. And by production plan, I mean the series of and combination of generators which have to be online, creating electricity to meet the customer demand for that time period. In the next tab of the planning application is where we really directly see the integration between plan analytics and decision optimization. So far in this example, we've seen variables, the generation levels and the costs associated to those levels. We've seen constraints. The generators have a ramp-up time, a downtime, and rules that constrain their operating scenarios. And reaching ahead a few tabs, we'll see exchanges or the option to buy electricity where it's really too expensive in terms of cost or pollution to produce directly. Example, the planning analytics user will increase the cost of producing carbon dioxide 100 times. Then select the optimization action button to recalculate the production plan. Selecting the optimize action button, the user kicks off the execution of a watching machine learning process that reads data from TM1, writes data, the results back to TM1, and integrates through the action button to launch the process in watching machine learning. User sees messages that the job was kicked off, was started, and the job completed successfully. And if you watch the chart in the lower left, the percentage of purple to blue, of coal to diesel, it will change, and the ratios of the coal produced to gas production will increase. And there we go. We see that there's more blue, and the plan has been optimized to reduce pollution, and it's going to increase the gas production or gas generation levels. So to recap, this demo illustrates the type of integrated solutions that are possible with plan analytics and decision optimization, and how now they are simpler to set up with a native integration, both in terms of data and functional experience with integration between action buttons and watching machine learning. In the next video, I'll show how this application is technically set up by going through the individual steps one by one. So thank you very much, and please watch the second video. Thank you. Bye-bye.